Let's start to study spectrum in depth. A general expression of a signal can be expressed as a weighted summation of sinusoids. Through Fourier research, the fact was established that an arbitrary continuous function can be represented by a trigonometric series. The first announcement of this great discovery was made by Fourier in 1807 before the French Academy. For real signal xt, we assume that it is a summation of cosine functions. Xt is a0 summation k is 1 to n ak cosine 2 pi fkt plus vk. From Euler's expression, cosine theta is half exponential j theta plus exponential minus j theta, or real part of exponential j theta. Actually, exponential j theta is cosine theta plus j sine theta. So we can express here the summation of exponent can be expressed as a multiplication of two exponentials, and for simplicity we denote xk. So for general expression of real part of complex number, we can use complex conjugate. Complex conjugate means we can replace the j instead of j by minus j. So, for example, 2 plus j3 conjugate is 2 minus j3. Real part of 2 plus j3 is a half 2 plus j3 plus 2 plus j3 conjugate. Then a half 2 plus j3 plus 2 minus j3. So 2. Like here. Actually x0 is exponential j 2 pi 0 t, because exponential j0 is 1. So x0 is amplitude of exponential j 2 pi 0 t, constant, so we call DC component. This means direct current. As you study in circuit theory. So when you look carefully the final equations, we can express the signal with pair x0 is the amplitude when frequency is 0. So here's 0, x0 as a pair. And when k is 1, the frequency will be f1. Then its amplitude will be xk over 2. In the case of minus fk, the magnitude will be xk conjugate over 2. So we can express pair until fk and minus fk. So when you draw this component in the graph according to frequency, then 0 will be x0 f1 will be x1 over 2 minus f1 will be x1 over 2 conjugate dot 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 until fk. So against 2 y-axis there's two sides, negative side and positive side. So you call it two-sided spectrum. The expression of this is a set of two tuples, frequency and amplitude, is called frequency domain representations. In contrast, xt like this is called time domain representation because here's t. But in the spectrum, we cannot find any t as a parameter. And we study further, and x0, as we explained, it can be expressed as exponential j 2 pi f0t when f0 is 0. And inside the summation, we can express as this a k, and that's defined minus fk is f minus k. So in such case, it will be a minus k. So it looks like more is complicated, but rewrite the equation as single summation terms. When ak is xk for k is 0, ak is half xk when k is integer, positive integer, ak is xk conjugate times half for negative integer. So spectral expression for xt, which is expressed as a 0 plus summation of cosine functions, can be expressed as using complex conjugate. Let me show an example for spectrum. Here xt is 10 plus 14 cosine 200 pi t minus pi over 3, 8 cosine 502 pi t plus pi over 2. 200 is 2 pi 100 t, 2 pi 250 t. So here 10 is 2 pi 0 t. So of 0, then the response related to f0 here 0, the amplitude is 10. So the spectrum will be 10 and 0 frequency. In the case of 14 cosine 200 pi t minus pi of 3, we can express with exponentials using Euler formula. j 2 pi 100t minus pi over 3 7. So we rewrite this for frequency. When frequency is 100, its amplitude is 7 exponential minus j pi over 3. So here, like this. In the case of minus 100 frequency, the amplitude is 7 exponential j pi over 3. In the case A cosine 500 pi t plus pi over 2, it will be same way, exponential j 2 pi 250 t plus pi over 2 plus exponential minus j 2 pi 250 plus pi over 2. So 4. Look at this. 250 frequency 50 will have 4 exponential j pi over 2. In the case of minus 250 hertz, four exponential minus j pi over 2 becomes its amplitude. So from time domain signal, and find spectral component like this, we call analysis. From a spectral component, we reconstruct time signal is synthesis. Okay, when we have spectral components like this, we can draw a graph of a spectrum like this. So here, zero frequency will have a 10 mega amplitude. In the case of 100 hertz, then it will be 7 exponential minus j pi over 3. In the case of minus 100 hertz, we'll have a 7 exponential j pi over 3. Okay, similarly, we have 250 and minus 250 hertz. Up to now, we studied the summation of two sinusoids. The summation of two sinusoids can be expressed of spectral components, and we can also draw spectrums. What about multiplication of two sinusoids? As you study in high school, so a multiplication of two sinusoids can be expressed as summation of two sinusoids. Let's prove it and let's derive the result. And cosine 2 pi f1t times cosine 2 pi f2t. Using Euler formula, we can express like this. Okay, and there's two terms in left side, left at the first term, and there's two terms in the second factor. So we can multiplication by term. This will be here 1 term will be 2 here 3 and 4. So we'll have 1 plus 2 becomes cosine 2 pi f1 plus f2t. And we'll have 3 plus 4 becomes cosine 2 pi f1 minus f2t. So it's sum and difference, and the magnitude becomes a half. So since we can express multiplication of two sinusoids as a summation of sinusoids, even signal with multiplication, we can find spectral components. Okay, here's another example. Is f1 is that to half exponential j 2 pi f1t, so half exponential minus j 2 pi f1t plus a half exponential j 2 pi f2t plus a half exponential minus j 2 pi f2t. So you can draw the spectrum. F1 has amplitude or half, and minus F1 is a half, and F2 is a half, and minus F2 also half. So it is we can express this one, this summation we can find from multiplication like this. Okay, so here the previous one is like this. From these relations we can have like this. Okay, let's show an example multiplication of two sinusoids. Here, from the previous results, we can directly use 2 cosine 2 pi 20t times cosine 2 pi 200t becomes cosine 2 pi 220 plus cosine 2 pi 150t. So when you multiply it, slow one is 2 cosine 2 pi t. Here is cosine pi 2 pi 200t. So when you make multiplication, it will be faster like this, and the outline of fast moved frequency called enveloped. Okay. This multiplication is used in our life. You have radio like this. We can see here AM and FM. So AM means amplitude modulations. Actually, the human voice cannot go to far distance. So, to send our voice too far away, we use modulation. So one of the example is radio. Radios, so high frequency radio is called carrier frequency. So we use voice, and the carrier frequency carry the voice to our radio. The expression is like this. There's voice Vt times cosine 2 pi fct. If Vt is 5 plus 4 cosine 40 pi t, then here will be 5 plus 4 cosine 40 pi t. This fast moving frequency is cosine 400 pi t. So when you multiply, then it looks like this. Then is envelope. Yes. And this is 5 cosine 400 pi t plus 4 cosine 40 pi t cosine 400 pi t. This is a half exponential j 2 pi 200 t plus a half exponential minus j 2 pi 200 t. This one becomes 2 cosine 2 pi 440 t plus cosine 2 pi 360 t. It will be 2 exponential j 2 pi 440 t plus exponential minus j 2 pi 440 t. Plus 2 exponential j 2 pi 160 t plus minus j 2 pi 360 t. So it will be exponential j 2 pi 440 t plus exponential minus j 2 pi 440 t plus exponential j 2 pi 3 t t plus exponential j 2 pi minus 3 t. So here (502) at 200 and minus 200, you can have here and 220, sorry, 220, 80. So here will be 180, 200, 220. It's 1. So 1, 1 minus 180 is 1. So minus 220 is 1. Okay. Thank you.